This is Professor Pelton. This is part 2 of Chapter 2, Section 4. Now we're going to do operations with complex numbers, reminding ourselves that I is the square root of negative 1 and I squared is negative 1. Okay, so we'll start with add and subtract, then we'll do some multiply and exponents. So order of operations, parentheses first. So that to remember here is there's a 1 in front of this. So I'm really distributing a 1 to each of these. This is what I'm really doing. So when I do that, I get 5 minus 11i plus 7 plus 4i. So if I rearrange these, I get 12 um, minus 7i, right? Sorry, my pen died there. I don't know what went up. There we go. These electronic pens. I need to get the new battery, I think. Okay, so same thing with subtraction. There's a 1 here. So if I distribute, I get minus 5 plus I. I'll distribute here. And this is a negative 1, so I get plus 11 plus 6i. So if I rearrange, I get negative 5 plus 11 plus I plus 6i. So if I add like terms, I get 6 plus 7i. Notice each time I'm keeping these in complex format. What I notice is the textbook will say keep the answer in complex format. Okay, so here in the parentheses, 3 minus 5i, those are not like terms, so I can't do the grouping symbol first, but I'll distribute, which is multiply. So I get 12i minus 20i squared, and of course we know 12i minus 20i is the square root of negative 1, which is why when I square I just get negative 1, right? So I get 12i minus 20 times negative 1, which is really positive 20. So 20 plus 12i gives me the complex form of that. Okay, so here again, in the parentheses itself, these are not like terms. I can't combine them, but I can distribute, right? So if I distribute, right, because this is multiply, I'm going to get 4 terms because 2 things times 2 things gives me 4 things. So I get, let's see, 7 times negative 2, so that's negative 14. 7 times 5, so negative 35i. 3 times 2, so that's 6i. And then 3 times the 5 gives me 15i squared. Okay, so that's negative 14. I can combine the I terms to get negative 29i. And then plus 15, and we know that the square root of negative 1 is I. So if I square it, I get negative 1, right? So negative 14 minus 29i plus 15 times negative 1. So it's really minus 15, right? And minus 14 gives me minus 29, minus 29i. There we go. Okay, last one. So again, in the parentheses, they're not like terms, so I can't do parentheses. So I'll do the exponent step. So 3i plus 1, right? And then 3i plus 1, okay? So the grouping symbols is the first step in the order of operations, right? The second level in the order of operations is, exponents, radicals, logarithms, stuff like that. And then the third step in the order of operations is the multiply and divide, right? So if I multiply here, I'm going to get what? 9i squared plus 3i plus 3i plus 1, right? When I distribute, because distribution is multiply, right? Okay, so if I distribute, substitute out, sorry, because the square root of, so I is the square root of negative 1. So I get what? Plus 6i plus 1. So I really get negative 9 plus 6i plus 1 because you square the square root. Square and square root cancel each other, of course. So if I rearrange these in the proper order, I get negative 8 plus 6i. Okay. Pause the video and try the student problems for yourself. Okay, so if we try the student problems, the first one is add, second one is subtract, third one is multiply, fourth one is multiply, and the last one is both multiply. I'm sorry, exponents with a multiply. Okay, so if I distribute a 1 here, I get 5 minus 2i plus 3 plus 3i. So rearrange them, 5 plus 3 minus 2i plus 3i. So that gives me 8 plus 1i, or just 8 plus I is fine, either one of those. The idea is you keep it in complex form, though, which is the a plus bi form, right? So a plus bi form is always the form that we want for all the answers whenever possible. Okay, so distribute a 1 and a negative 1 here. So 2 plus 6i minus 12 plus I. So if I rearrange 2 minus 12 plus 6i plus I gives me negative 10 plus 7i. Because remember, just a single I is really one I, right? It's really a one I. Whoops. No, we'll get a space in there. Okay. Last three. All right. So again, you can't do anything in the parentheses. They're not like terms, but I can distribute, which is multiply. So I get 14i minus 63i squared. So 14i minus 63 times the square root of negative 1 squared, which is 14i minus 63 times negative 1. So therefore 63 plus 14i. I don't know what happened to that plus there. All right. Pen's a little jumpy on me today. Okay. There we go. All right. So again, there's nothing in the parentheses I can do because these are not like terms. But I can certainly distribute, which is multiply. Okay. So 30 minus 35i plus 24i, and then minus 28i squared. Okay. Excuse me. So we have 30 minus 11i minus 28 times the square root of negative 1 squared. That's not very good, negative 1. Try that again. So we have 30 minus 11i minus 28 times negative 1. So that's really positive 28, right? So I get 58 minus 11i. Okay. So when we're doing any operations, which is what this is about, order of operations is important, right? So number 1, grouping symbol. Well, I can't do anything in the grouping symbol here, right? Level 2, exponents and radicals, right? Also logarithms when we're not doing logs in this chapter, right? Okay, so I'll do exponents and radicals. So 2i minus 3 times 2i minus 3, right? Because that's squared means multiply by yourself, right? And then 3 is multiply and divide. So there's no divide here, but there's a multiply, which is distribute. So 4i squared minus 6i minus 6i plus 9. And then the last step is 4, which is, add and subtract. Okay. We're going to simplify first, though. So simplifying gives me 4 times the square root of negative 1 squared minus 12i plus 9. It's a little bit of adding, but simplify is something that comes between every single step. Simplify is not one of the steps in the order of operations. All right, so I really get, whoops, that's the square root of negative 1. What am I always doing there? There we go. So we have 4 times negative 1 minus 12i plus 9. All right, so we can finish the adding. So that's really negative 4 plus 9, right? So 5 minus 12i. Okay. All right. So let's look at a division 1 on the next page, which will use a very specific method called conjugates. So if you look in this book and the materials we teach in this course, there's a bunch of different conjugates we do. There's irrational conjugates. In this case, it's complex conjugates. And the premise is always the same. We're trying to get rid of something in the denominator. In this case, it's a complex term because it has a 2 minus 5i. So what you have to keep in mind is, what am I trying to get rid of here? The 7 plus 4i is not a problem. That's already in complex form, but it has a 2 minus 5i on the bottom. So that's the problem. So I can't write the final answer in a plus bi, which is what I want. Okay, so what I need to do is use a conjugate. So the conjugate of a minus is a plus. So in this case, I'm going to multiply by 2 plus 5i over 2 plus 5i, which will conjugate the bottom, which is what I want. So on the top, when I distribute, I get 14 plus 8i um, plus 35. Whoop, that's not very good. Plus 35i. And then let's see, 5 times 4 gives me 20i squared. Okay. And on the bottom, if I distribute, I get 4 minus 10i minus 10i minus 25i squared. Okay, so we'll combine like terms on the top and the bottom and do a simplification. So I get 14 plus 43i plus 20. And at this point, I think we can skip ahead and we know that I squared is really -1 without doing a double substitution. And then 4, you notice the 10s, I'm sorry, that's not minus 10i, that's plus 10i, right? Because when I go here, it's minus 10, and here's plus 10i, right? Okay, so I have minus 25 times -1. Okay, so we can go one step further. So the 20 is really negative on top. So what I'm really going to get is a -6 plus 43i. And then on the bottom, we're going to get 29. You ask yourself, well, how did that help me? It's still not an a plus bi form. Well, I did get rid of the I in the bottom, the complex part. Okay, so now I can split the fraction, right? Although that's a -6, correct? Because it's 14 minus 20, not a positive. So it's -6 over 29 plus 43 over 29i. And now I'm in complex form. Okay, where this is my real, that's my A, and that's my B, right? Okay, all right, pause the video, try the student problem for yourself. Okay, so in this case, the conjugate I need to get rid of is the 4 plus I. So I'm going to multiply by 4 minus I, because again, the denominator is the problem. The numerator is not the problem, right? So regardless of what's on the top, the bottom is what you're truly working with in this chapter, or any chapter when you're dealing with conjugates. Okay, all right. So if I do, so again, if it's plus, it's minus. As minus is plus, always the opposite. So if I distribute the top, I'm going to get 20 minus 16i. Let's see, minus 5i, and then that's double negative, so that's plus 4i squared over, okay, so on the bottom I get 16 minus 4i plus 4i, right? And then minus I squared. Okay, so we simplify now. I get 20 minus 21i plus 4 times, and we can substitute out the I squared. And on the bottom, I get 16 minus -1, because the 4 i's cancel. Okay, so on the top, it's really minus 4 from 20, right? So I get 16 minus 21i. And on the bottom, I'm just going to get 17. So I've accomplished what I wanted, which to get rid of the I. So now it's just a number. I can split the fraction now. So 16 17ths minus 21 17ths I. Because again, you have to remember that the A and the B in a complex number, they just have to be real. They can be fractions, decimals, whole numbers, whatever is happens to be. It doesn't have to be a nice countable number. Okay. So principles of a square root. I'll go into 2 depths about the principles of roots, or specifically square roots in this case. But so what you'll notice when you use the online websites, it'll give you multiple answers depending on what you're working with and what complex planes. We're going to stick with a very basic answer, which we have here, which is dealing with the negatives. So the thing we have to keep in mind in all these problems, which is why I leave them for the end, is a radical counts as a grouping symbol, because in this country they use PEMDAS in their book since the 70s. And the problem with PEMDAS is students think parentheses is the first step in the order of operations. In reality, it's grouping symbols, right? It's absolute values, radicals, parentheses, brackets. There are many things that count as a grouping symbol, one of them being a radical. So we need to do the radical first, right? So that's inside a radical, inside the radical. So if I break this down, right, this is -1 times 3 times 3 times 2. And the 8 is -1 times 2 times 2 times 2. Okay, so if I break this out, I'm going to get the square root of 1 times the square root of 3 times 3 times the square root of 2 minus the square root of -1 times the square root of 2 times 2 times the square root of 2. Okay, so you can see that some of these break down. Whoop, that's -1. What did I said one thing, but did another. Okay, so -1. So that's an I. That's a 3, and that's a root 2. That's an I. That's a 2. And that's a root 2. So I get 3 root 2 I minus 2 root 2 I. So you should write them with the extra multiply symbol just for the I itself, because it's always unclear when handwriting with students whether the I was in the radical or not, which it's not. It's outside the radical. But just to make it doubly clear, do that. So this is really like terms now. So 3 root 2 minus 2 root 2 is 1 root 2 I, or just simply root 2 I. Okay. If you want to put it in complex form, you put a 0 in front of it. Did I specify here? Standard and standard complex form. Okay. So if I do standard complex form, I get 0 plus root 2I. Ah, my pen jumped again. I think that's an indication the battery's going dead. So that's what I thought was happening since the beginning. Okay. All right. Next two. Okay, so again, grouping symbol first. So what you have to work in the grouping symbol first because that is level 1 in the order of operations, right? So grouping symbol, right? So what I have here is -1 plus the square root of -1 times 5, right? Squared, which is really -1 plus root 5 I for the square root of -1. Okay, so level 2 is exponents and radicals. So I'll do the exponent. So I have -1 plus root 5I times -1 plus root 5I. Okay, now I can do level 3, which is multiply and divide. So if I multiply, I'm going to get -1, -1 is +1, minus root 5I minus root 5I. I'm electing not to write the 1 just to save some room, but probably not necessary either way. Plus root 25I squared. Okay, so 1 minus 2. Uh-oh, I did it again. Let's fix that. Minus 2 root 5I, right? Because I have 1 here and 1 here, right? Plus 5 times -1, because again, I squared is -1. So it's really -5 plus 1, so -4 minus 2 root 5I. Okay. And again, it's fine because root 5 is a real number, which is all A and B have to be. 2 root 5 is the real number, right? Okay. So again, grouping. Oh, so I'm sorry. Level 4 is add and subtract, which is what we did last. We added and subtracted like terms on the bottom with the 5 and the 1, or -5 and the 1. Okay, so again, this is a grouping symbol right here, which has to come first. So -25 plus, come on, plus, please, thank you. All right, and -1, so 50 is 5 times 10, right? So that's 5, 5, and 2. So you have -25 plus 5 root 2 times I, because the square root of 25 is 5, and the negative 1 comes out as I, over 15. Okay, so what I really get here, if I break this up into the fraction, so there's no exponents or radicals to do, but there is multiply and divide, so we're going to do the division. So negative 25 over 15 plus 5 root 2I over 15, right? So I'm doing the division essentially. Okay, so if I simplify 25/15ths with division, I get negative 5/3. And if I simplify 5 over 15, that's going to give me a third. So it's minus, oh, we lost the negative, or did I? No, I don't think I did. I think we're good. So plus root 2 over 15I. I think we're good. Okay. All right, pause the video, try the student problems for yourself. Okay, student problems. Again, the problem I see with a lot of these, whenever there's a negative square root or negative root whatsoever, people are not doing the inside of the grouping symbol first. Because again, what I'm trying to indicate with these problems last is the radical is a grouping symbol, right? So if I break this down, I get negative 1 and then 3, 3, 3 for 27, and then 48. All right, so that's 4 times 12, right? So 2, 2 for the 4, and then 2, 2, 3 for the 12. It gives me 48, correct? Okay, so what I really have here is the square root of negative 1 times the square root of 3 times 3 times the square root of 3, plus the square root of negative 1 times the square root of 2 times 2 times the square root of 2 times 2 times the square root of 3. Okay, so if I do each of these in the subgroups, I get get 3, I get root 3, I get 2, I get 2, and I get root 3. So what I really have here is 3 root 3I plus 4 root 3I, which is 7 root 3I. Okay, I like it. All right, last two. So again, I need to break up this first. So this is negative 2 plus root 3. And if I take the negative 1 out, it's an I, right? So I've done level 1 in the order of operations, which is the grouping step. Level 2 in the order of operations is exponents. So negative 2 plus root 3I times negative 2 plus root 3I, right? And okay, level 3 in the order of operations is multiply and divide. So if I multiply, which is distribute, I get 4 minus 2 root 3I minus 2 root 3I, and then positive and positive give me plus 9, I'm sorry, root 9, because root 3 and root 3, sorry. So root 9I squared. Okay, so I get 4 minus 4 root 3I plus 3, because the square root of 9 is 3. I think I was one step ahead of myself before. And the I squared is negative 1, right? That's how we're going to get square. Let me fix that, make it better squared. Okay, so now we can do the last step in the order of operations, which is add and subtract. So I have 4, and that's really a minus 3, so I have 1 minus 4 root 3, and then I gives me in complex form. Okay, I like that one because it has all the 4 steps in the order of operations. Okay, all right, last one. So again, I need to break this down, right? So negative 14 plus, if I break down 12, I get 223, right? 4 times 3 is 12. Okay, because again, this is a grouping symbol which needs to come first. So negative 14 plus 2 root 3, and then the I over 2, right? Because the square root of 4 comes out as a 2 and the negative 1 comes out as an I. So then I can do my division, because I've done grouping symbol. There's no exponent radical step to do. I mean root 3, but root 3 is a decimal answer, so we don't want that. So division comes next. 14 over 2 plus 2 root 3 over 2I. So you can continue with the division and get negative 7 plus root 3I. Okay, and that is the end of part 2.